This is question 7 from paper 3-3 from the June 2020 exams from Cambridge International. Up the top right of the screen here, you'll find a card that will bring you to the playlist that has all my solutions for the other questions in this paper. And below the video, you'll find a link to the image of this question, so you can try it before looking at my solution. This question is fairly long and awkward, part B and C at least. But part A, there's no real excuse to part A. It's partial fractions. It comes up very regularly. As a student, if you're going into the exam, you need to know how to do these because they'll come up at least every year or two. So all it is, we write this fraction as two fractions. I'll just write this out again. I'm going to use a lot of ink in this question, unfortunately for me. Yeah, we're going to rewrite this as, when the bottom row has two products like that, we can rewrite it separating them both out. 2x plus 1, each as their own fraction. And what number goes up here? That's really the question. Some students are really good at it. They just do it in their head and they figure it out. But for me personally, and for most of you guys, we'll do it this way. We put in just two placeholders, A and B. This could be any two letters you want, really, that'll help you understand it. And we just multiply the right side back to look like this. So we just add them together like we've always done. This multiplies here, these multiply each other, we add the tops together. So let's do that. I'll try and do it quickly to get all the x's. There'll be a 2a multiplied by an x will appear. 2a. There'll also be then a 2b multiplied by an x will appear, so that's 2b. You can do this slower, that's fine. And what else will have to be done? I'll get 1a and I'll get minus a b, so I'll get plus an a and minus a b, and that's all the top row. The bottom row, honestly, I wouldn't even bother writing it in the exam, but just to show you guys, I'd just write this again. If I was doing this on a piece of paper myself, I just would skip this, put a few dots there. Or something like that, because I'm not going to use it. Right, what I'm going to use is the knowledge that this side equals this side. They're the same. I made up the letters, but there are two letters that make this equal to this. Bottom row is equal to bottom row. They just cancel. That's why I'd get away without writing it. But then the top row equals the top row. That must mean there must be two numbers and 0 x's up here. This must be 2 and this must be 0. Over here, there's 0 x's. There is in fact 0 x's over here. So from that piece of information, we get the fact that 2a plus 2b must equal 0, because there must be 0 x's, and a minus b must equal 2. I'm sorry, 2 it must equal. This one we can divide everything by 2, so we'd get a plus b equals 0. Yeah, and you very often get things like this in partial fractions. Just solve this simultaneous equation. It's quite easy. You can probably do it in your head at this point. I'll just add the two together. I'll get 2a, these will cancel, equals 2. A must equal 1. And then if a is 1, b must be minus 1 to get 0. A is 1, b is minus 1 to get 2. So b is minus 1. And that's it. Instead of writing fx, I better write it out again myself. I'll put it in up here. This is equal to 1 over 2x minus 1, 1 minus 1 over 2x plus 1. So that's rewriting fx as partial fractions. That's what they want. Put this down the bottom of your question, I'd suggest. Make sure the examiner knows what you're looking for. Now we're going to use this bit of knowledge here in part B. So I'll just clear this out of the way and we'll move on to that. In part B, they ask us to find fx squared. Now they tell us what it looks like though. They ask us to show that this is the answer. Basically what they're asking us to find fx squared, and we're going to hope it looks like the one they gave us. So let's do that. We could just square this, but a clue would be that they probably want us to square this one here. So let's go ahead and get this squared. And think of this just as a plus b squared. You know how to do this. We square the first one, a squared. First one times the second one is ab, and the second one times the first one is ab again. So we get 2 of them, and then we get b squared here. Very standard. It should be no different here. We get the first one squared, 1 over 2x minus 1 squared. We will get the first multiplied by the second. that'll be a minus, yeah, a minus 2, because there'll be 2 of them. And again, the first multiplied by second, the bottom rows will look like this: x minus 1, 2x plus 1. And then we'll get the second one squared here. Minus squared is a plus. We'll get plus, 1 squared is 1, 2x plus 1 squared. Okay, we checked it. Is that what they wanted? Close. They wanted this term. They wanted this term. But they had 2 separated ones in the middle. But we just need to notice, this is just fx. Well, it's minus fx, in fact. So we really just need to write these 2 instead of this one. So let's write this again. Again, I'm going to run out of lots of ink on this question. 2x minus 1 squared. This one here is this identical to this, but it's minus. Just be careful. This is a plus, this is a minus. So we get minus 1 over 2x minus 1. Minus minus is a plus. 1 over, is that the way they actually have it? They do. Okay, brilliant. Plus this one, and this one here, we'll leave the way it was fine. 2x plus 1 squared. And that's actually part B. It's not too difficult at all, part B. Very scary because there's lots of writing and lots of, my arm is nearly sore doing it now. But other than that, it's pretty okay. I'm going to need lots of room for part C, so I'm going to clear this out off the board. I'll write these again, but I'm going to write them in a different way just so I have lots of room. Okay, this is what I'll write for part C. I'll explain why I'm doing this. What they're asking is this part here. They actually give us the exact answer, so they want us to confirm we get this. We shouldn't really use this except to check our answer. That's all we should be using this sort of thing for. I'll just jot it in there. Now, instead of using fx squared, even if you didn't answer part A or B, they gave you in part B that this is equal to this. So instead of writing this, you could write this. Instead of the integral of this, it's the integral of all. I should have an integral of all of this out here. But that's also difficult. So let's do each of them separately. That's why I wrote them all down here. Instead of doing all of them at the same time, we're going to do each of them separately here. Dx, integral of dx. Now you could do them all in one line. It's fine if you are happy to do these sort of things. I think this should be a squared, not squared, and not squared. Okay. Now these are actually quite similar. So I'll do this one and this one in depth. And then I'll just write the answer to these two. Because, well, I'll show you how I can do that. When you get more confident, you will be able to. But you might have to do all of them the long way. So each of them are just their own integration question. We do it as we always do. Can I do it in my head? Is it simple? No. Well, let's try substitution. U is equal 2x minus 1. We substitute that in and we see what we get. First, let's integrate that so we can replace dx. Du dx is equal to 2. I'll have to write this small, I'm afraid, because I might run out of room otherwise. Rearrange this, we get dx is equal to a half du. Okay, we'll use that substitution on this guy here. And if I rewrite this, we'll get the integral of 1 over u squared. And instead of dx, I can put du in and a half. The half will go out here. Now, how do we do this? This is equal to a half u to the minus 2 du. We'll continue it on up here and keep each of these separate. We'll have 2 lines for each of them maybe. How do we integrate this? Well, this is now simple. It's in a simple form here. We add 1 to this number. So the integral of that is, well, a half. Didn't move anywhere. The integral of this is u. We add 1 to this. We get minus 1. Then we divide this number by minus 1. Well, dividing is the same as multiplying. Dividing by minus 1 is the same as multiplying by minus 1. And, well, that's it. Let's just replace u back again. We'll get minus a half 1 over 2x minus 1. U to the power of minus 1 is 1 over whatever it was. So that's it. We just need to evaluate that between 1 and 2. Because 1 and 2 was still in all these. And that's it. We'll do that in the next line. So that's how we do that. Lots of students can actually jump straight to this answer here. But that's fine if you can. Otherwise, use the substitute. If you're getting the right answer all the time, continue. Continue whatever you're doing. Okay, let's do something similar with this one. Most students can do this one without substitution. But I'll go ahead and use it. I could use a different letter, but I'll just use the same one because most students do. Although probably shouldn't use the same letter in the same question. And you've already used u for, but I'll go ahead. Actually, u is the same, so it doesn't matter. 2x minus 1. Again, very similar. I'll get the identical thing. I'll get dx is equal to a half du. I'll be able to rewrite this integral as minus, again, the half will appear outside. Dx I'll replace with du and a half. And I'll replace I'll replace this with a u, or u to the minus 1 will appear here. Or 1 over u is fine as well. So how do we integrate this? This is a special case. It comes out as the natural log. So the answer will be minus a half natural log of u. Or if we write that with the x still there, we get minus a half natural log of 2x minus 1. Alright, that's that one integrated. Now we're just integrating each of these as we go along. This one I think we can probably do in our head, especially with this one here as a template. So the answer to this one will come out as natural log of 2x plus 1. And here's how you could do this maybe when you get more practice. It's 1 divided by something, so we're going to get the natural log. And then we're going to have to accept the fact that we sort of cheated with this 2x in here. It's not simple as 1 over u. It's 1 over this complicated thing. So we're going to have to use the chain rule there and to replace the complicated thing with a u. Really, that just means differentiating in here and multiplying by it. The derivative of this is a half. That's where this half appeared from. And that's it for that one. That'll give us the answer. Again, this is between 1 and 2. It's between 1 and 2. The last one, we'll take inspiration from this as well. This is going to be equal to, it's 1 over something squared. Well, that will always become 1 over something. It's for example, u to the power of minus 2 will always come u to the power of minus 1. We'll always have to adjust the fact that we use the chain rule, so we have to differentiate the thing inside here. So a half's going to appear outside. And then we're also going to adjust for the fact that we divided by that minus 1. Where did we do that here? We did it here. This minus 1 suddenly appeared. So that's also going to appear up here. So we'll get another minus 1 appearing. Alright, if I clean this up, we'll get, minus, actually, no, that's fine the way it is. Minus a half, 1 over 2x plus 1. And this is still evaluated between 1 and 2. Okay, so that's all of them done separately. You could do that anywhere on your page. Do it over on the right side of the page, perhaps. If this was your exam, usually do things like this. Maybe when you get to this question, just do as many separate ones as you need over here, and then put them back in this line here. Alright, I'm going to rub this out, and when we bring it back, I will just have underneath this line I is equal to this plus this, or minus in this case, this plus this plus this plus this, all in one straight line, and we're going to evaluate all at the same time. Okay, so here's the 4 answers we would have got previously, and let's put a big bracket around all of these because we're evaluating them between 1 and 2 still. And we can clean a lot of this up. Look, a half goes into all of them. So actually let me do that on this line. Because I'm in marker, I can get away with this. Let's take the half out of everybody, and we'll just put it out here on the side. We can do that at the very end. There is a half appearing, but 2/5, which is a bit worrying. But let's see how it all comes out. Let's see. I guess we could put these together now. No, let's do it later when we get the numbers in. Let's put the numbers in now. So we put 2 in first, and then we take away putting 1 in. We put 1 in and take that away. So let's put 2 in first. This is equal to a half, and the half can stay outside forever. Because even when I put the 2 or the 1 in, he's going to be outside. So let's leave him out here. We will get 2 2's minus 1 is 3. So we'll get a minus a third. We'll get minus natural log of 3. We'll get, this is be 5 now. We get plus natural log of 5. 5 over, okay, still not appearing. We'll get 1 over 5 here. Minus 1 over 5. Alright, let's put 1 in and we'll take away that thing. So instead of a minus, let's be a plus. We put 1 in, we get 2 minus 1, that's just 1, and that's plus 1. If we put 1 in here, we get 1. Natural log of 1 is 0, actually. So I'll just put in 0 plus 0. I put 1 in here, I get natural log of 3. We're taking this away, so we'll have to minus natural log of 3. And let's see, this one here will become a plus, and when we put 1 in, it'll be 1 over 3. So plus 1 over 3. And that's it. Let's see, the 1 over 3 actually cancels with this guy here. No, these unfortunately do not cancel. Now let's see, we'll get natural log of 5 over 2 of these. Oh, I've been looking at this one for those numbers. It's this one we want to get 5 over, so it'll be this 5 divided by 3 times 3, because there's 2 of them, so it's 9. So that natural log actually works out quite nicely. And 1 minus a fifth. Oh, 1 minus a fifth is 4/5, but we're going to get half of everything, so 2/5. This looks like it's good. Let's clean it up just to make sure. But from what I can see in my head, it looks good. First thing, I'm going to get these natural log 3's together, because that might be the bit people have trouble with. We'll have let me write natural log 5 first. Natural log 5, and then we'll have minus 2 natural log 3's. If you agree with that, there's a natural log 3 and a natural log 3. There's 2 of them. What else have we got? We've got 1 minus 1/5 is plus 4/5. And yeah, I'll just continue this on like this. There's not much more. Natural logs. The rule for taking away natural logs like this, once they're the same log to the base e, log to the base e. Well, I can't do it with this 2 here, so let's rub that 2 out and put it up here. 3 squared. That's where that 9 is going to appear from. Okay, so the rule is when we take away, it's sort of like dividing. This is the same as, half hasn't gone anywhere yet. This is the same as natural log of 5 divided by 3 squared, or 9 in this case. And this is a plus 4 over 5. Half into both of these. This is a half into 4/5 is 2/5. 2/5 and a half. Oh, we just want to leave the half out front, don't we? Plus a half natural log 5 over 9. Alright, a mess. Unfortunately, so many students get so much of this question right and make one mistake somewhere here. And they're going to lose marks. There's nothing else to be done about it. You are going to lose marks in this exam if you do not get the full correct answer out. Although they gave you the answer this time, so you should have been able to find where your mistake was a little easier perhaps. But that's just the way of life. You have to be so careful going through the question. Practice, practice, practice. If you have any questions for me, for anything I did I make any mistakes, anything you need clarification on, just put them in the comments below. I'll do my best to answer. Thanks for watching and have a great day.